So now let us try and understand the shape of these pulses. Okay, how will be visible to us? Right now I told you the concept, what is happening. Okay, now let us see what will be the shape of the pulse in the string when it is getting reflected. What we will be able to see. Okay, so first thing is I am taking it to fixed end. Alright, so if it's a fixed end and the pulse is over here, what we have to do, we have to assume that its reflected pulse is somewhere here and it's coming from this side. It's like this. Okay, then only we are going to see what will be the shape of the string at all the moment. This is imaginary, it is not there, we are assuming it. Okay, why assumed it below? Because reflected wave, when we are moving over here, it will be below it. Okay, so let's assume it like this. Right, now what's going to happen the next? Make it like this over here, and here it will be in this way. Now you will know that a similar thing we have already done before in the previous classes. Okay, so now this pulse and this pulse is going to enter into interference zone, and then we are going to write the resultant output. Okay, let's see. Now suppose that this one, I am going to take it this side also. Okay, no need to worry over here, just check. Okay, and what about the reflected one? This one also will come this side. What is going to happen? It will be here. Okay, this is going in this direction, this is going in this direction. Now just check it. What is happening? Now this reflected pulse, which is this, came this side. It's on this side. So this only is visible to us, this is not visible to us. This is imaginary part. This part is imaginary part. Why imaginary? Because string is connected up to this point only. Whatever is this side is imaginary side. Okay, so this portion only is available here. Now what is the shape of the pulse? Just check. Now here, what is the amplitude of this one? This pulse, it's minus a. Why minus a? Because it's below. And what is the displacement of this point over here? It's plus a. So when this plus a and this minus a combine, the answer is 0. Same way this point you see. If this point's displacement here is y1, so here this point's displacement is also y1 but negative, so answer is 0. So in this particular case, in which the incident pulse would have been like this, and the reflected pulse is here like this. So how this string will appear to us? After this, next instant the string will appear to us like this. Why? Because it's the interference of this pulse and its reflected pulse. Now this reflected pulse came from where? This came from this part of the incident pulse. Okay, this part of the incident pulse is getting reflected and came like this, and both of these are getting interference, so it became like this. Now what will happen? This part further will go ahead. Okay, let's take this part further ahead and see what's happening. See. Okay, now same way reflected pulse also. Exactly same way reflected pulse also. That means image. How will that be? Okay. So reflected pulse is here now. It's here. Okay. This is going this direction, this is going this direction. Alright, so what will appear to us in this case? In this case, where is the interference zone? Interference zone is here. Only this is interference zone. Okay, now you can see over here, its displacement is a lot more than this displacement. This is minus a, this is 0. So pulse will be like this. This pulse will be as it is here. Now this is interference zone. Now this is a lot more than this one, or maybe same also, that's also possible. So this and this we will be adding. Same way, this is maximum amplitude over here, and this is certainly not the maximum. So here it will be in the downward side. So how will be the pulse? The pulse will be like this. Mostly the pulse will be in this way. Further, what will happen? Further, what will happen? This side will reach over here. It will be like this on this side. This is imaginary. So in this time, this pulse will come over here. This is purely reflected wave. So this pulse will be visible to us. Okay. So how the shape will be, the total shape, as I told you in the previous case when the string was fixed. In that one pulse will come like this. It will become straight, and then it will go the other way around like this. It will come like this, become straight, and then reflected pulse like this. It will go in this way, so like this. Okay. Now one more question you will see. In that one you can understand in a better way, because these round pulses are there, its additions are difficult. Okay. So what we will do is we will try a triangular pulse, and with the triangular pulse we will try and understand how to get the shape of the wave. Okay. Now suppose we have a triangle pulse like this, and it's moving in this way towards the fixed end. Okay. Let's give it values. Maybe let's say this is 1 centimeter, 1 centimeter, and let's make it as this also 1 centimeter. Okay, it's moving in this direction. So this is fixed end. Okay, now what we'll do, here we are going to assume the imaginary pulse. Exactly similar. Like this. Okay, let me make it in a smaller size. Let me make it smaller size. Okay. This is fixed end. 1 centimeter, 1 centimeter, 1 centimeter. Same way here. And you know that this is imaginary. It's coming towards this side. 1 centimeter, 1 centimeter, 1 centimeter. Okay. Next instant, what will happen? Come like this, and here it will be like this. This is coming this side, and this is coming this side. Okay, no issues. Now, up to this, there is no interference zone. Now, when this is going to come here, this is going to go there, there are interference zone. So suppose, where shall we take it? Suppose here. I'm going to take that here, they are going to meet at this point. So suppose this is half a centimeter. Okay, so something like this I am saying you. This point will reach here. Okay, so when this point reaches here, so this point will reach here. So it will be here. Okay. Alright. So where is the interference zone? Can you see that? Interference zone is this. Because this side anyhow is not visible to you. Only this we have to take care of. This part. This to this. This is your interference zone. Okay. So now see. This is 0.5 centimeter we chose. So this is also 0.5 centimeter. Alright. But here you see. Here this point. Because this point and this point's amplitude you have to add. This point's displacement because of this reflected wave is 0. Whereas this is something. Because here you can say, okay, this is somewhere like 0.75. So this is 0.75. So 0.75 and this 0. So it will remain 0.75 over here. But here at this point, this is plus 0.5, this is 0.5. So how will this wave appear to you? How will this pulse will appear to you? Now see that. This all will not be visible to you. Okay. It will be visible to you like this. From here it will go directly in this way. Are you able to understand? This is because of the addition of the two. Again, I'll try and understand that. It was like this. Okay? At this particular point, it was like this. At this particular point, this was 0.5. This is also 0.5. Minus 0.5 plus 0.5 means 0. So, string will be here. At this point, this was 0.75, this was 0. So, addition gives 0.75. So, up to this, everything is fine. From here, it will go directly to 0 itself. Okay. Further, let's see. Now, let's see that if 1 centimeter point is reaching over here, then what will happen? Okay. So, 1 centimeter. Okay. This is going like this. And the below one also. Now what is going to happen? Just check that. This is minus 1. This is plus 1. That means minus 1 plus 1 is 0. Here and here. Also, whatever is this up, same is down. So 0. So here every point when they are interfering, what they are giving us? 0. So how will be the pulse, the next pulse? Further also we can see when this will be further this side, this will be further going that side. That also we can check. Now check it here. Okay, this is going in this direction. Okay, now reflected one. Okay, now where is the interference zone? This is not visible to you, this side is not visible to us. This and this is not visible. So where is the interference zone? This is interference zone. This all is interference zone. Now add it again. This is this point. This displacement is much less than this displacement. So when you add this with this one, obviously this point will be down. Okay, it will be somewhere here. Okay, same way this point here, this is 0 and this point here is whatever minus. Okay, so how will be the pulse visible to us? It will be like this. This all is not there. It will be appearing to you in this way. Are you able to understand? Okay, this will appear to you like this. And the next instant, this will continue to move towards left. So it is the example of interference. What interference? Main pulse and its reflected image through fixed end. When you are going to combine them, you are going to get the shape of the pulse. Certain times, question will be asked from this. Okay. Now let us see at free end how can we get. If free end is given, then what to do? They are also the same thing. We have done it already. Okay, when free end is there, how to solve that? If I take this as the pulse, okay, then we will take its image over here. Okay. Why like this? Because free end's reflected image is like this. We have checked it already. Okay. So then we will be finding out the interference of these two. Check it if suppose this is A and this is A. What's going to happen? Let's check. When this reaches over here, okay, same way this one also will reach over here. What will happen to the pulse? Will this be visible to us? No. A of this one and A of this one. A of left to right and A of right to left. When they added it becomes 2A. So how will this be? This will be visible to us. You have to add amplitudes of both. Okay, and finally what will happen? This incident pulse we can show in that side and this reflected pulse, actually we can show this side. What is the final thing? Final thing will be something like this, and it will go in this way, as I explained you in the previous class. So this is how we have to understand interference happening in the reflected waves, so that we can find how will be the shape of the pulse due to reflection. Okay? We can solve more questions based on that, and we can understand how it can be solved. Okay? It's the same case that we solved before, so I hope you can do that. Now let us see where we are going to use these concepts when we are talking about reflected waves. Okay, so sometimes it happens that we will have two strings connected. Okay, two strings connected in series. Two strings connected in series. Okay, now suppose this is one string here. Okay, and we have another string. This is another string. Okay, both are different kind of strings. You can say this is denser and this is rare. So if we are going to give pulse or incident energy, so one pulse is given to it, what will happen at this end? Now this is being a denser one, this end will be called as fixed end, or it will act like a fixed end. So what will happen? From here, when the energy goes over here, the energy will be reflected, and some energy will be transmitted also, because this is not totally fixed end. Okay, so some energy will be transmitted, or you can say refracted, and some energy will be reflected also. Okay, so here we have to use the same concept that we learned. That's a fixed end concept. That means at this denser boundary, the reflected will have phase change by 180 degrees. But if the reverse case is happening, if this is denser and this is rarer, this is denser and this one is rarer, and here is the pulse, and when it reaches over here, what happens? There will be transmission, definitely transmission will be there, and there will be reflection also. But how will be the reflection? In reflection, it will come from the same end like this. It will go like this, because it will be treated as a free end. Okay, so when it goes from denser to rarer, this joint is treated as free end, whereas when it's denser medium, it is treated as fixed end. So in this case, reflected wave will have phase change of pi, whereas here reflected wave will have no change of phase. And in both the cases, transmission will have no change in phase. Transmitted wave will be in same phase as that of incident wave, whereas in reflected wave, because of the denser medium, will have change of phase of pi. Because of rarer end here, there is no change in phase of pi, or change in phase is not there at all. Okay, this is the concept you have to remember. Now what we are trying to find, what will be the relation between the amplitudes of incident wave, reflected wave and transmitted wave. Okay, we are going to get the formula. Now let us see. What will be same when the wave is moving from one medium to other medium? Frequency. So here also, when the wave is moving from one string to the other string, frequency still will remain same only. That we have to remember. Okay, so here let's take an example. I am taking an example from denser to rarer medium, or rarer to denser medium. Okay, so here and here is denser. This is denser. And whatever is the outcome of this we can apply it with the other case also, when it moves from denser to rarer. So it will be applicable for both. So here is incident one. It's moving in this direction. let's say its amplitude is AI. Okay, it reached to this end. This is the transmitted one. Transmitted. Okay, its amplitude is AT. And here, this is the reflected one. And its amplitude you can say is AR. Okay, what we know is energy of incident wave is distributed among transmission and reflection. We know that. Okay, so I am writing here power incident equal to power reflected plus power transmitted. Okay, this here velocity, this velocity I can assume is V1 and this velocity I can assume as V2. What about this velocity? This velocity is same as V1. Why? Because omega is same. Medium here did not change because it's coming back to the same medium, so K is also same. Omega, that means frequency is same, wavelength is same, so obviously velocity also will be same. So incident wave and reflected wave will have same velocity, but here velocity is different. Now you can ask me why? Because in this case omega remains same, but K is different. When K is different means wavelength different. When wavelength is different means velocity also different. Okay, so let's write now power incident, power reflected, power transmitted. What is power incident? 1 by 2 mu omega square AI square into velocity. Half mu1 you can write if you want because medium is different. So half mu1 omega square AI square V1 equal to 1 by 2 mu1 omega square AR square V1 plus half mu2 omega square AT square V2. Okay, this half we can cancel. Alright, now this mu1 we can change. We know that we derived a relation which is V equal to root over T by mu. Okay, or we can say V square equal to T by mu. So mu equal to T by V square we can write. So this mu1 I am writing as T by V1 square. Omega square AI square V1. Same here also. T by V1 square mu1 omega square AR square V1 plus here also T by V2 square omega square AT square V2. Now you can ask me why tension is same in this case. Because they are connected in series. It's a series connection of the strings. Whatever tension you are pulling up from here, same tension will be over here. Okay? I can give you an example also. If suppose that this end I make fixed here and suppose you are pulling it from here with F. Okay, so this F will be transmitted over here and will go to this one. Okay, and here reaction will be there which will be opposing it. We call as normal contact force. So the force that you are transferring from here, as it is that force goes, okay, and it goes up to this point. And this force only we are calling as tension over here. Okay, because the size of the string is not changing. So that means some force is there which is opposing it also, which we are calling as tension. Okay, so throughout the string, tension will be same. So this tension also we can cancel over here. This V1 gets cancelled here also, and here this V2 gets cancelled. So what are we getting? We are getting over here omega square AI square. This omega also we can cancel in fact. Omega is also same. So let's remove this one. Yeah, we are getting here AI square by V1. Bring this one also here. Minus AR square by V1 equal to AT square by V2. Okay, this is AI square minus AR square by V1 equal to AT square by V2. This is our equation number 1. Okay, we go for another equation. What is that equation? Let's see. The other equation is related to amplitudes at the junction. At junction I am writing AI plus AR equal to 80. Okay, amplitude of incident wave plus amplitude of reflected wave equal to 80. Now why this? Because this is happening at one string only. Okay, the wave is going like this and reflected pulse is coming like this. It's happening on the same string. So the sum of these two is equal to 80. Now you can say that little while ago I was saying energy of incident wave is equal to energy of reflected wave and transmitted wave. Absolutely correct. In this one, reflected waves in amplitude is 180 degree out of phase. Now when you are going to add it, you have to take care of phase also. So when you are going to add it, in fact you are subtracting it, because phase is pi is the phase difference between the two. Okay. So AI plus AR equal to 80. This is our second equation and this is our first equation. Both we are going to solve so that we can get the amplitude. Okay. So here in question number 1, I can write this as AI plus AR into AI minus AR equal to V1 by V2 into 80 square. Now AI plus AR I know already is 80. Put it over here. 80 AI minus AR equal to V1 by V2 into 80 square. This and this gets cancelled. Okay. Now what I want here, I want relation between 80 AR and AI. One relation already I got, but now I will be trying to find out how much is 80 and how much is AR. Okay. How much is 80 and how much is AR. So what I will do is here, in place of this 80, I am going to write here AI plus AR. So AI minus AR equal to V1 by V2 AI plus AR. Okay, so then take AR one side and AI one side. So AI, bring this one here, 1 minus V1 by V2 equal to AR 1 plus V1 by V2. So what we are getting? AI V2 minus V1 equal to AR V2 plus V1. So AR value is equal to V2 minus V1 by V1 plus V2 into AI. Okay, we got AR in terms of AI. Same way 80 also will be getting. Okay, 80 is already this, we can put the value into this one or into this one. AI plus AR equal to 80, so we can put this value in this also to get the value of 80. So see then, AI plus AR value, this is AR value, V2 minus V1 by V1 plus V2 into AI equal to 80. So what we are getting, let's check that. AI we can take common, then what we are getting, 1 plus V2 minus V1 by V2 plus V1 equal to 80. So AI, this is V2 plus V1 plus V2 minus V1 by V2 plus V1 equal to 80. V1 gets cancelled, so we are getting here AI 2 AI V2 by V1 plus V2 equal to 80. Okay, since the example we have taken is the wave is going from rarer to denser medium, so we can predict about the amplitude of reflected and transmitted wave. So if this is rarer and this is denser, this is incident wave, this is reflected and this is transmitted. So in this case particularly, because it's a denser medium, we know that the speed in this one, this is V2 and this is V1. So we know that V2 will be less than V1. If V2 is less than V1, you can see that AR, which is reflected one, is coming negative. AR will be negative. Okay. Transmitted one, you see, V2 is less than V1. Okay. So amplitude, this AT, will be less than AR. Okay. AT will be less than, because this is denser and this is rarer. So its energy will be more, reflected energy will be more, and transmitted energy will be less. So hence amplitude of transmitted will be lesser than amplitude of reflected one. Which case, when it moves from rarer to denser. But when it comes from denser to rarer, transmitted one's pulse will be, amplitude will be more, and reflected wave's amplitude will be less. In which case, when V1 is less than V2. Okay, when it moves from denser to rarer, I'll show you. When you move from denser to rarer medium, this is denser and this is rarer. Okay, if this is V1 and this is V2, okay, in this case V2 will be more than V1. Alright, here V2 is more than V1. That means amplitude of reflected wave will be positive. But this amplitude will be a lot less in this case than AT. Why? Because this is rarer medium, so more energy will be transmitted than reflected. Okay, so that's all for now. In our next class, we will solve problems on this one also, and on interference of the pulses in strings also. Thank you.